All right, so welcome to this video. In this video, we'll be looking at the basics of matrices, and these are the key concepts that we're going to cover. So I've listed all the concepts, okay, that you can cover under basics of matrices for all the students that are taking linear algebra as a course. Okay, so the first concept is the construction of matrices, okay, given certain conditions. So how do you construct a matrix, or how do you make or form a matrix from scratch when you're just given the conditions of the I and the J? Okay, so the I will be representing the rows, the J the columns. So if you are given those conditions, how can you construct a matrix? We also look at the addition of matrices, subtraction of matrices, the trace of a matrix, the transpose of a matrix. So there on the transpose, you have to pay attention uh, on the transpose of a product of matrices. Okay. We'll also look at the polynomial functions of matrices. Okay, how can you write a polynomial in terms of the matrices? Look at the inverse, the properties of the inverse, and then solving and proving matrix equations using the property. Okay. Another thing that we are going to look at will be the commutativity of matrices. So when do we say that these two matrices are commutative? And that property is very important, as you will see later on when we'll be doing the questions. Okay, we'll also look at symmetric matrices, the skew symmetric matrices, the invertible matrices, singular matrices, equality of matrices, and another important thing, okay, the reduced row echelon form for the what? For the matrices. Okay, so this is very important because it's going to guide you throughout the course. So if you don't know how to represent a matrix in reduced row echelon form, then you won't be able to do anything, okay, for the future topics that are coming. So this is very key here. You have to understand this concept. Okay, so how do we do that? How do you reduce a matrix to row echelon form? We're going to use what we call as elementary row operations. So you will see as we are doing the examples, and then finding the inverse using these same row operations. We're going to talk about that. We're going to talk about what orthogonal matrices are. And finally, we'll look at the normal form or the canonical form of the matrices. Okay, so these are the concepts that will be covered. And I'll be using questions, okay, from this tutorial sheet here. So you can see this tutorial sheet has, that is question one there. Okay, so this is question one. You can see we are constructing matrices from scratch, and then all the way up to question 21. Okay, where we have there are some polynomials of the matrices, diagonal matrices, and the like, and also powers of the matrices. So we're going to be discussing all these questions here, and explanations to all of them will be available on our website, which is discretelearning.com. Okay, so if you want to access full videos for all the questions here, just head over to discretelearning.com. You're going to find the videos there. Okay, so let's get into the solving now. All right, so in this video, we are going to learn how to construct matrices, okay, from scratch, given specific what? Conditions. So we're going to use this question here to help us. So here they're saying find the 5 by 5 matrix A, whose entries satisfy the stated condition. So you can see we have three conditions here. We'll have to construct a matrix for all these what? Conditions. So before we do that, okay, we'd like to learn what rows are and what columns are, and also what elements of a matrix are. So for example, if I've been given my matrix, okay, as A is equals to 1, okay, 2, 3, 4. So let's say this is my matrix that has been given there, okay? So these numbers that are in this matrix here, or these elements that are in this matrix here, are what we call as the elements or members of the what? The matrix, okay? So each of these elements that are in this matrix, okay, they will belong to a certain row and to a certain what? Column. So when you talk about rows, okay, these are just the horizontal lines or the lines that move from left to right or right to left in a matrix. So meaning that you just draw horizontal lines like this. Okay, so how many horizontal lines have I drawn in this matrix? I've drawn 2. So it means the number of rows there are just what? 2. Okay, and then we can also talk about columns. So what are columns? So these are the lines that run vertically, or the lines that run from top to bottom or bottom to top. So let me draw vertical lines within this matrix. So you can see I'm only able to draw 2 vertical lines. So that means that I have how many columns? 2 columns. Okay, so now the order of the matrix, okay, the order of the matrix is going to be given by the number of rows multiplied by the number of columns. So meaning order, okay, for the matrix above is just going to be equals to the number of rows, which is 2, multiplied by the number of what? Columns. So what does the order of the matrix tell us? The order of the matrix tells us how many rows and how many columns we are going to have, okay, in a specified what? Matrix. So this order is saying 2 by 2, simply meaning there are 2 rows, okay, and 2 columns. That's what the order tells us to do. Okay, so I said each of these elements sits in a certain row and a what? A certain column. Okay, so for example, if I look at this one here, okay, so we said the rows are the horizontal lines like this, okay? So we can see 2. So this is my first row here, and then this one is my second row. And then the columns are the vertical lines. So meaning this is my first column, and then this is my second what? Column. So each of these elements here, okay, they will be in a specific row and a specific what? Column. So if I get, for example, this one here, this one is in the first row, okay, and first what? Column. So now the row number, okay, is indicated by the letter I, okay? So row number is indicated by the letter what? I. And then the column number is indicated by the letter what? J. Okay? So if you want to describe this element 1 here, okay, we are going to say this element, okay, you can pick any letter of your choice. For this example, I'll pick small letter A. So for me to describe this element 1 here, I'll say element A, okay, I, J. Now I'm going to replace the IJ, okay, with the column number and the row number where this one is. So you can see this one is in the first row. So I'll write A, I'll replace the I, which represents the row number, by 1, okay? And then this element again, it's in the first column. So I'll replace the column number by what? 1, okay? So this simply means this element here that I'm describing as A11, okay, it's the element in the first row, okay, and the what? The first column. All right, so now if we're to describe these two here, okay, we're going to say that is A, okay, it's in the first row as well, so it will be 1, and then it's in the second column, so it will be A12. So this will be equals to these 2 here. And then this one, the A11 was equals to 1. So now how can we describe these 3 here? Okay, so that 3 will be A. So we see that the 3 is in the what? The second column. So it will be 2. And then it's in the first row. So it will be A21 is equals to 3. Okay, what about this 4 here? This 4 there will just be A. It's in the second row. And it's in the what? Second column. So it will be A22 is equals to what? To 4. So you've seen that each element, okay, is in a specified row and a specified what? Column. So having known this now, we can use this knowledge to construct a matrix, okay, if we've been given a formula in terms of the I's and the J's, okay. All right, so now let's look at the question that we've been given there. So this question says construct a 5 by 5 matrix. So what does 5 by 5 matrix means? Okay, so this simply means we have 5 rows, okay, and 5 what? Columns. Okay, and then we've been given a formula here for this matrix A, for example, this one here. So they're saying the ith row and jth column element, okay, should be given by I plus j plus C A. So I'm going to say, okay, matrix A is equals to, so we have 5 rows and 5 what? Columns. Okay, so meaning matrix A should look something like this. Okay, so the first element here will be in the first row and first column. So it will be A11. Okay, the second element will just be A12 because this is now second column. It will be A13, third column, A14, fourth column, A15. This would not this will be the fifth column like that. Okay, and then now I go to the second row, so it will just be A21, okay, A22, A23, A24, and then A25. Okay, third column, third row, it will be A31, A32, A33, and then A34, A35. Okay. Fourth row, it will be A41, okay, A42, and then A43, A44, and then A45. So the last row now will just be A51, A52, A53, and then A54. Finally, we're going to have A55. Okay, so this is the 5 by 5 matrix that they want us to construct for this first condition there. So now take a look at Aij. So Aij has been given as I plus j plus what? 1. Okay, so these i's and j's, they're just indicating the row number and the what? The column number. So for example, if I get A11, so A11 simply means the I is 1, the j is 1. So in this formula, I'm just going to put 1 plus 1, okay, is plus 1, which is outside there. This will just be equals to what? To 3. Okay, just be equals to 3. And then what will be my A12? So this one will just be, now the I is still 1, but the j is 2. So using this formula, where there's I put 1, plus, where there's j, I put 2, plus the 1 there. This will just be equals to what? To 4. Okay, and then the next one will be I13, which will just be equals to 1 plus 3 plus 1 is equals to 5. Okay, the other one will be A14 is equals to 1 plus 4 plus 1 is equals to 6. And then the last one here in the first row, it will be A15, which will just be equals to 1 plus 5 plus 1 is equals to what? 7. Okay, so the first elements that are going to sit in the first row here, the first one will be 3, and then 4, 5, 6, 7. Okay, so I'm seeing that they're increasing by 1. Okay, as they move in this row. Okay, so I'm just going to erase these guys here and then put the numbers that we found there. Okay, so we found that A11 is 3, the next one is 4, the next one is 5, the next one is 6, the next one is 7. Okay, so we found the first row. We can now move on to the others. Okay, we can now move on to the others. So let's find A12. So this will just be 1 plus, A21, not A12. We've already found A12. So we are now here. So that is A21, which will be equals to. Now the I is 2, the j is 1. So using this formula, it will be 2 plus 1 plus 1, which will just be what? 4. Okay. The next one will be A22, which will just be 2 plus 2 plus 1 is equals to. This will be 5. Okay. The next one will be A23, which will be equals to 2 plus 3 plus 1, which will just be 6. The next one is A24, which will be equals to 2 plus 4 plus 1, which is equals to, which will be equals to, this is 7 now. Okay, and then the last one in that second row, just be A25, which will be equals to 2, okay, plus 5 plus 1, which will be equals to what? To 8. So these are the numbers that will sit in the second row here. So I'm just going to come here, then I'm going to erase this part, and then I put the numbers that are supposed to be there. So the first one is 4, okay, and then I have 5 there, and then 6, and then 7, and then 8. Okay, let's find the third row. Okay, let's find the third row. So the third row, okay, we are using these ones here. So the first one there is A31, meaning the I is 3, the J is 1. So that would be 3 plus 1 plus 1, which would just be equals to, which would be equals to what? This is 5, right? Okay. Then the next one is A32, which will be equals to 3 plus 2 plus 1 is equals to 6. Okay. And then A33 will be equals to 3 plus 3 plus 1 is equals to 7. Okay. The next one will be A34, which will just be 3 plus 4 plus 1 is equals to, this will be 8. Okay, and then the next one will be A35 is equals to 3 plus 5 plus 1 is equals to 9. So these are the numbers that are going to sit in the third row. So I'll come here and erase the A's, and then I put the numbers there. So there is 5, and then 6, 7, 8, and then 9. Okay, so now we can see a pattern here. Okay, this was 3, 4, 5, 6, 7, and then the next row starts at 4, 5, 6, 7, 8. The next one starts 5, 6, 7, 8, 9. So meaning that this one here is just going to start with 6, 7, 8, 9, 10. And then the other one there will start with what? 7, 8, 7, 8, 9, 10, 11. Okay, so I'll leave the others, okay, as your exercise. You can confirm uh, um, what I'll write here, okay, but these are the answers that you're going to find if you solve through them, okay. So we're just following the pattern now. You can see 3, 4, 5, okay, so meaning this one will be 6, this one will be 7, 8, 9, 10. Okay, and then the other one there, since this is 6, this will be 7, 8, let me write the 8 properly. So 8, 9, 10, 11. Okay, but you can try to check, okay, by doing whatever we are doing here. So that is it there, okay? So on A, we've constructed a 5 by 5 matrix, okay, using the formula that we've been given there, depending on where the element sits, okay? So meaning which row is it in and which column is it in. We managed to construct a 5 by 5 matrix. Okay, so that's the answer for part A. Let's look at part B. Okay, let's look at part B. Okay, so we're still constructing a 5 by 5 matrix, but now we are constructing matrix B, okay, which has the elements Bij. So again, this will just be B11, okay, and then B12, B13, B14, and then B15. Okay, next one will just be B21, B22, B23, B24, and then B25. And the next one will be B31, B32, B33, B34, and then B35. Okay, so the other one will be B3. Oh, that one should be 4 now because this is the fourth row. So 41, B42, B43, and then B44, B45. Then let's write the last one. So the last one here will be B51, B52, B53, and then B54, B55. So you can see 5 rows, okay, 5 columns. So no wonder it's a 5 by 5 matrix. Okay, so now let's use the rule that we've been given here. So the rule that we've been given is this one here. They're saying the element Bij is simply equals to minus 2 plus I to the power j minus 1. Okay, so that's the formula that we are going to be using there. Okay, that's the formula that we're going to be using there. Okay, so here you have to be very careful, okay, because we have a power. Okay, so let's start with the first row. So the first row, I'll start with B11 is equals to, so where there's I, where there's j, I just put 1. So this will be minus 2, okay, plus I is 1, okay, j is 1, and then minus 1. So you see that in the power there, it's 1 minus 1, which will just be 0, right? So any number raised to the power 0 is what? 1. So this will just be minus 2 plus 1, which will give me what? Minus 1. Okay, what about B12? This will be equals to minus 2 plus, okay, the I is still 1, I mean, still 1, but the power there, the j is 2 minus 1 is equals to. So this will be what now? Okay, so this will be minus 2 plus 1 to the power 2 minus 1. So 2 minus 1, it gives me 1. So 1 to the power 1 is still 1. Okay, 1 to the power 1 is still 1. So minus 2 plus 1 still gives me minus 1. Okay, the next one is B13, which will just be equals to minus 2 plus the I is still 1, and then the j is 3 minus 1. So this will be equals to, so this guy here, okay, it will be 1 to the power 2, because 3 minus 1 is 2. 1 to the power 2, still 1. Okay, so this will still be minus 1. And we can say the same for B14, okay? Still be the same thing, because 4 minus 1, whatever here, whatever the power here, this one won't change, okay? So it will still be minus 1, and the B15, which is minus 2 plus 1, 5 minus 1, still be minus 1. Okay, so the first row will have minus 1s everywhere. So can erase this and then put in the numbers there. So this will be minus 1, minus 1, minus 1, minus 1, minus 1. So that's the first row. Let's look at the second row. Okay, so the second row, we start with B21 is equals to, okay, so minus 2 plus, the I now is 2, because this is 2. So that is 2 to the power 1 minus 1. Okay, so this will be 0 in the power. So 2 to the power 0, it's 1. So minus 2 plus 1, that will still be minus 1. Okay, what about B22? This will be minus 2 plus B2 minus 1 is equals to. So now take a look at this guy here. This will be 2 minus 1, which will be 1. So it is 2 to the power 1. 2 to the power 1 is 2. So minus 2 plus 2, that will just give me a what? A 0. Okay, and then B23 will be equals to minus 2 plus 2 to the power 3 minus 1 is equals to. So now here it will be 3 minus 1, which is 2. So 2 to the power 2, that is 4. Okay, minus 2 plus 4, that will be positive 2. The next one will be 2 to the power, B24, which will be equals to minus 2 plus 2 to the power 4 minus 1, which will just be equals to. So 4 minus 1, it's 3. 2 to the power 3, it's 8. So minus 2 plus 8, that will give me 6. Okay, and then B25 will just simply be minus 2 plus 2 to the power 5 minus 1, which will be equals to. So 5 minus 1, that is 4. So 2 to the power 4 is 16. 16 plus minus 2, that will simply be what? 14. So I'll replace these as my column, my row 2, not column, but row 2. So row 2 is going to have minus 1, 0, 2, 6, and then what? 14. Okay, let's go to the third column. Okay, so the third column, I'll start with B31 is equals to minus 2 plus, where there's I put 3, where there's j, I put 1 minus 1. So this will just be a minus 1. Okay, B 3, 2 will be equals to, this one here is minus 2 plus 3 to the power 2 minus 1, which will be equals to, so 2 minus 1 is 1, 3 to the power 1 is 3. So 3 plus minus 2, that will be a positive 1. And then B 3, 3 will be equals to minus 2 plus 3 to the power 3 minus 1, which will be equals to 3 minus 1, that's 2. 3 to the power 2, it's 9. So 9 plus minus 2, that will be positive 7. And then B 3, 4 will be equals to minus 2 plus 3 to the power 4 minus 1 will be equals to, 4 minus 1 is 3. 3 to the power 3, it's 27. 27 plus minus 2, that will be 25. Okay, the next one, 3, 5. Okay, B3, 5 will be minus 2 plus 3, 5 minus 1 is equals to. So here, I have 5 minus 1 in the power, so that will be 4. So 3 to the power 4 gives me 81. Okay, and then 81 plus minus 2, that will just be 79. Okay, so I'll replace my third row with these entries here. So let me replace them. So I'll say my third row has minus 1, 1, 7, 25, 79. Okay, so here there's no pattern that we can see, so meaning we have to find all of them. Okay, so let's find the one for the fourth row. So B4, 1 is equals to minus 2 plus the I is now 4, and then 1 minus 1. Okay, this will just give me minus 1. B4, 2 is equals to minus 2 plus 4, 2 minus 1. Okay, this one here, we can see that in the power, that is 2 minus 1, so that is 1. 4 to the power 1 is 4. So 4 plus minus 2, that will be positive 2. And then B, 4, 3 is equals to minus 2 plus 4, 3 minus 1 is equals to, 3 minus 1 is 2, 4 to the power 2, it's 16. Okay, 16 plus minus 2, that will be 14. Okay, what about B4, 4? B4, 4 will be minus 2 plus 4 to the power 4 minus 1. Okay, minus 1 is equals to, so this would be like 4 to the power 3, right? So 4 to the power 3 is equals to 64. 64 plus minus 2, that would be 62. Okay, what about B4, 5 is equals to be minus 2 plus 4, 5 minus 1 is equals to, so 5 minus 1, that's 4. So 4 to the power 4, it's 256. And then plus minus 2, that would be 254. So I'm going to replace this fourth row with these guys here. So I'm just going to erase this part. Okay. And then I put in minus 1, 2, 14, 62, and then 254. Okay, so just remaining with the last row, which is fifth row. So let's find the entries in the fifth row. Okay, so B5, 1 will be equals to minus 2 plus 5, 1 minus 1. This will just be minus 1. B5, 2 will be equals to minus 2 plus 5, 2 minus 1 is equals to, so this one here will just be 5 to the power 1, right? Which is 5, and then plus minus 2, that would be 3. B5, 3 is equals to minus 2 plus 5 to the power 3 minus 1, which will be equals to, this will be 5 to the power 2, which is 25. 25 plus minus 2, 23. Okay, B5, 4 is going to be minus 2 plus 5, 4 minus 1, which will be equals to. So in the power there, that is 3. So 5 to the power 3, and then minus 2. Okay, I get 123. And then here it will be B5, 5 is equals to, this one will be minus 2. Okay, minus 2 plus 5, 5 minus 1 is equals to. So in the power, I'm going to have 4, so that is 5 to the power 4, and then minus 2. or plus minus 2. So that will give me 623. So these are my entries in the what? In the fifth row. So let's put them there. Then we'll be done with part B. So that will be minus 1, 3, 23, 123, 6, 23. Okay, so this is the matrix B constructed from this row here that we are given there. Okay. All right, so that's it for part B. Okay, let's try to do part C. Okay, let's try to do part C. So part C, we have to pay attention to the rule that we've been given, okay, because it's not direct as part A and B were. Okay, so let's look at C now. So I want to construct the matrix C, okay, which has Cij as its entries. So this will be C11, C12, C13, C14, and then C15. So that's the first row. The second row will be C21, C22, C23, C24, then C25. Third row, C31, okay, C32, C33, C34, C35. Then C41, okay, C42, C43, C44, C45, C51, C52, C53, C54, C55. Okay, so those are our entries for this matrix. But now let's take a look at the rule that they have given us there. Okay, so they have said if the modulus of j minus I is greater than 1, okay, then the answer that we should get is 1. Okay, if j minus I, we take its modulus, is less than or equal to 1, okay, then our answer should be what? Should be I. So what do they mean? Okay, so let's say, for example, I'm finding C11 here. C11, okay, I'll be using this. So it will be the modulus of j, which is 1, minus I, which is 1. So this will just be the modulus of 0, which will just be what? 0. So you ask yourself, is 0 greater than 1, or it's less than or equal to 1? So we see that 0 is less than or equal to 1. So the answer for such, okay, if it's less than or equal to 1, will be what? A minus 1 there. That's what they mean. Okay, so now let's start finding all these elements that will be here. Okay, so I'm following this rule here. So the first one will be C11 be equals to the modulus of 1 minus 1, which will just be what? 0. Okay, so modulus of 0 is simply 0, and this is less than or equal to 1. Okay, so meaning the answer for this guy will just be what? 1. Minus 1, I mean, according to this. Okay, because what I get from the modulus is less than 1. So the answer is what? Minus 1. So that's the minus 1 that I've put there at the end. C 1, 2 will be equals to 2 minus 1, which will just be 1. And the 1, okay, is less than or equal to 1. So it means that one again will just be what? Minus 1. What about C13? So that would be 3 minus 1. This would be modulus of 2, which is equals to 2. So now 2 is greater than 1. Okay, so meaning the answer here would be the one which is greater there, which is what? 1. So I put 1. C1, 4 is equals to modulus of 4 minus 1. Modulus of 3, which is 3 greater than 1. The answer there will be 1. What about C15 is equals to, the j is 5, so 5 minus I, which is 1. This will be equals to modulus of 4, which will just be equals to 4, which is greater than 1. So the answer there will be what? 1. Okay, so the first row here, the answers are these ones: minus 1, minus 1, 1, 1, 1. Okay, so I'm going to erase and then put in the numbers. So there's minus 1 again, Let me write this in red. So minus 1, minus 1, 1, 1, 1. Okay, so those are the entries there. Let's move to the second row, following the same rules. What's happening now? Okay, so these are simple things, guys. Okay, these are simple things. They just need your time. So let's construct the entries for this row here. So the first one is C21 is equals to. So you can see the J is 1, the I is 2. So following this formula, it's J minus I. So that would be 1 minus 2, which will just be the modulus of minus 1. Okay, modulus of minus 1, it's 1. So this one, it's less than or equal to 1. So the answer there will just be what? Minus 1. Okay, and then C, 2, which will be equals to 2 minus 2, which will be equals to 0. This will be equals to 0. 0 is less than or equal to 1, so the answer there is minus 1. C, 2, 3 is equals to 3 minus 3 minus 2. Okay, so 3 minus 2, that would be the modulus of 1. Okay, so this one is less than or equal to 1. So the answer there is minus 1 as well. Okay, what about C2, 4? This would be 4 minus 2, which will just be the modulus of 2, which is equals to 2. And we see that 2 is greater than 1, so the answer there is positive 1. C2, 5. Okay, modulus of 5 minus 2, which will just be the modulus of 3, which is 3, which is greater than 1. So the answer there is 1. So I can replace the entries in the second column. So that would be minus 1, minus 1, minus 1, 1, 1. Okay, let's deal with the third column. The third row, sorry. Okay, it's not columns but rows. Okay, so the third row now will be C3, 1 is equals to 1 minus 3, which will be the modulus of minus 2, which will just be 2. 2 is greater than 1, so the answer there is 1. Okay, C3, 2 will be equals to 2 minus 3, which will just be the modulus of minus 1, which will be 1, which is less than or equal to 1. So the answer there is minus 1. C3, 4, 3, 3, sorry. This will be 3 minus 3. This will just be modulus of 0, which will give me 3 minus 3 is what? 0, 0. Okay, this will just be 0, which is less than or equal to 1. So the answer there is minus 1. C3, 4 is equals to 4 minus 3, which will be equals to the modulus of 1, which is equals to 1, which is less than or equal to 1. So the answer there is minus 1. Okay, the last one, C3, 5. It will be 5 minus 3. So it will be the modulus of 2, which will be equals to 2, which is greater than 1. So the answer there is what? 1. Okay, so those are the entries that I'm going to put. Those are the entries that I'm going to put in what? Okay, those are the entries that I'm going to put in. Okay, in the third row. Okay, in the third row. All right, so in the third row, that's what we put there. So let's put it. Okay, let's put it. All right, so yeah, I hope I haven't made any mistakes there. Okay, let's just do a quick go through. So it's modulus of 2 greater than 1, 1. Okay, modulus of 1 greater than, or I mean less than or equal to 1, minus 1. Okay, all right, so what we get there is 1. Let me use red. So 1 minus 1. Okay, and then minus 1 again, and then minus 1, and then 1. So that is our third row. Okay, that is our third row. Let's look at now the fourth row. Okay, fourth row. So we erase this. So the fourth row, okay, we have C41 is equals to 1 minus 4, which will give me the modulus of minus 3, which will just be 3. So 3 is greater than 1, so the answer there is 1. Okay, the answer there is 1. C, 4, 2, which will be equals to the modulus of 2 minus 4 is equals to the modulus of minus 2, which will just be 2. So this is greater than 1. The answer there is 1. Okay, the next one is C, 4, 3, which will be equals to 3 minus 4. So modulus of minus 1, which will just be 1. 1 is less than or equal to 1. So the answer there is minus 1. Okay, what about C, 4, 4? This one will be 4 minus 4, which will just be modulus of 0, which is equals to 0. And this here is going to be less than or equal to 1. So the answer there is minus 1. Okay, what about C, 4, 5? This one will be 5 minus 4. So it will be the modulus of 1, which will just be 1, okay, which is less than or equal to 1. So the answer there is minus 1. Okay, so those are the entries that I'm going to put in the fourth row. Okay, so we have 1, 1, 1, and then, we have 2 positives and then 3 negatives. So minus 1, minus 1, minus 1. All right, so let's solve for the last row. Okay, so the fifth row, using the same formula. So it will be C15, which will just be equals to, using this formula, of course, J is 5, I is 1. So this will be the modulus of what? 4. Okay, so the modulus of 4 is 4, which is greater than 1. So the answer there is positive 1. So C5, 2 is equals to 2 minus 5 to be the modulus of, so here I made a mistake. That should be 1 minus 5. Okay, so that is 5 minus 1. Hey, what am I doing now? Okay, so let me start this. So this is C51, right? Okay, this is C51. So meaning that I have my J as 1, my I as 5. This is what I have. And then the modulus of minus 4, which will still be 4. So 4 is greater than 1, okay? Meaning the answer there will just simply be 1. Okay, and the next one is C52, which will be equals to, this will be 2 minus 5, okay? So this will be the modulus of minus 3, which is 3 greater than 1, okay? So this will just be 1. C53 will be equals to 3 minus 3 minus 5, which will be the modulus of minus 2, goes to 2, which is greater than 1. So the answer there is just 1. Okay, the next one is C5, 4. So this one will be 4 minus 5, which will be the modulus of minus 1, which will just be 1, which is less than or equal to 1. So the answer here is minus 1. The last one will be 5, 5 is equals to the modulus of 5 minus 5, which will just be 0. 0 is less than or equal to 1, so the answer there is what? 1. Okay, so we raise this and then we put in the values for the row. So that will be 1, 1, 1, minus 1, and then minus 1. All right, so we've constructed the matrix C. We've also constructed B and A. So that's how you can easily construct a matrix, okay, when you've been given specific what? Conditions. All right, so now let's look at this question here. Okay, so the question says, let matrix A be a 6 by 6 matrix defined by Aij gives it 2 if the I is equals to J, It gives a -1 if the modulus of I minus j is equals to 1, and it is 0 when none of these above conditions are met. Okay, so here this question is simply asking us to construct, okay, or to find or to form a 6 by 6 matrix based on the information that we've actually been given there. Okay, so before we even do that, we need to understand the notation and the terminology that are being used there. Okay, so here they've said we have this matrix A, which has the entries Aij, and the Iij's are being given by this piecewise function here. So if I write Aij, okay, the I represents rows, okay, or the row number. The J represents the column number. Okay, it represents the column number. So for example, if I just write a simple matrix here, I say my matrix A is equals to, and then I have a 5 there, a 2, let's say 0 here, and then a 1. Okay, so you've seen that if I go to this entry here, 5, it will be in which row? Remember, the rows, they move from left to right or horizontally. Then the columns move from top to down or vertically. So this one here is my first row. This one is my second row. This one here is my first column. This one here is my what? Second column. So the 5 here, it's in the first row and then second column. So we're going to indicate it as this 5 here is just the element A, 1, 1. You can see I've written 1, 1 there. So meaning it's in the first row and the first column. That's what we mean. So A11 here would just be equals to 5. Okay. What if I say A22? What do you think that would be? Okay. I'll just go to the second row and then the second column. I'll find the 1 there. So this one here is our A22, meaning second row, second column. So it will just be 1. So that's what this connotation here mean, what we've been given there. Okay, so now here we've been given a piecewise function that will help us determine a certain entry in this 6 by 6 matrix. Okay, so let's first write a 6 by 6 matrix. We see how it's going to look. So 6 by 6 matrix simply means we have 6 rows and 6 columns. That's what it means, as simple as that. So I'm going to say matrix A is going to be equals to, okay, so I write A11, A12, A13, A14, A15, and then A16. So I now have 6 columns there. Okay, and then now I go to the second row. It will be A21, A22, A23. Okay, because this is the third column, second row. A24, A25, and then A26. Okay, I continue. This will be A31, A32, and then A33, A34, and then A35, A36. That's what we have. Down there we have A41, okay, A5, yeah, what am I doing now? A42, I went to the fifth row, and then this will be A43, there I have A44, okay, and then here it will be A45, then A46. Okay, I go to my fifth row to be A51, A61. I don't know why I'm going to 6. This is still the fifth row, so it will be A52, A53, and then A54, okay, and then A55, and then A56. So I'm just remaining with the last row, which is the sixth row, right? So it will be A61, A62, A63, and then A64, A65, and then A66. Okay, so that is our 6 by 6 matrix that they want us to find or to construct, okay, or to write down explicitly. Okay, so let me draw my bars here to make it look like a matrix. Okay. Okay, so this is my matrix A, and it is a 6 by 6 matrix. Okay, so now we have to replace, okay, all these my A somethings, we have to replace them with the actual numbers, and we'll be following this guide here. Okay, so in this guide, they said if I is equals to J, okay, meaning the answer there is just going to be 2. So if I have A, IJ, where I is equals to J, then the answer will just be 2. So meaning everything here, you can see in the main diagonal, it will just be like having, the first one will be A11, okay? The other one will be A22, A33, A44, A55, and then A66. In all these entries here, the I is equals to the J. So that is just going to be 2. So this will just be 2, this will be 2, this will be 2, this here will be 2, this here will be 2, and that one also will be 2. So I'm going to replace all these diagonal elements. You've seen them. I'm going to replace them with a 2. Okay? So I'm just going to erase the diagonal elements that we had there. Okay, and then replace them with the what? With the 2. So according to this rule here. So I'll just say uh, the first one is the 2 there. 2, 2, 2, 2, 2. Okay, we've done the first part. We're still a long way to go. Okay. Um, can erase this now. I go to the second condition. So the second condition in my piecewise function said I'm going to get a -1 if the modulus of I minus j is equals to what? 1. Okay, so what numbers can give me a 1 if I subtract them? Okay, just to have it, those numbers just have to be consecutive numbers. Okay, like numbers that follow each other. So I'm going to look for the A and I, J that have consecutive numbers. So what do I mean by consecutive numbers? Entries such that have numbers such like 1, 2. So the numbers should be following each other so that when I subtract them, I get the modulus is going to be 1. So I'll just take an example. I'll get this entry here. You've seen the numbers there are consecutive, 1 and 2. They are consecutive. Even 2 and 1 are consecutive. So if I get this one, my I is 1. So I get modulus of I is 1 minus j is 2. Okay. So the modulus of this will be -1, which will just give me a 1. So it satisfies this. So meaning this entry here, I'm just going to replace it with a -1. Okay, and it will be the same for all the terms that have consecutive numbers, like again, this 2, 1. So that 2, 1, the I is 2, the j is 1. So modulus of 2 minus 1 is just going to give me a 1. Okay, and if it gives me a 1, then it satisfies this condition of being a -1 there. So I'm going to replace all the entries that have consecutive numbers like 1 and 2, the numbers that follow each other, or 2 and 1, okay, 3 and 4, 4 and 3, all those numbers that are following each other like that, like they have a difference of 1. Doesn't matter if it's a negative or positive because the modulus makes them positive. I'm going to replace all those entries with a -1. That's what I'm going to do. Okay, so I'll start in the first column, first row here. I'll erase this and just put a -1 there. Okay, so add the -1. These ones are consecutive. So I'll erase again this guy and replace with a -1. So which other ones are consecutive? Okay, we see that here I have 2 and 3. So 2 and 3 follow each other. So I'll erase this and put a -1. Okay, in this column, in this row, what do we have? 3 and 1, they do not follow each other, but 3 and 2 follows each other. So I erase, add a -1. Okay, any other number that are following each other? This one here. Okay, so I erase this because that's 3 and 4. I'll put a -1. Okay, I'm done with the third row. Fourth row, which numbers are following each other? This guy and this guy. They have 4, and this is 4 and 3, and then this is 4 and 5. So they are following each other. So I'm replacing those with a -1. Okay, so it's very easy to construct these things. Just have to understand the definition. Okay, what about the fifth row here? Which ones are consecutive? Okay, 5 and 4, 5 and 6, they're consecutive. So I'll erase them and replace them with a 1. So I just add -1 there and then -1 there. Okay, any other numbers that are consecutive here? Yes. Okay, I can see 6 and 5 there. This is consecutive, so I'm going to say that is a -1. Okay, so that's what I have there, and I think they are done. All the A's with I and J that are consecutive, they are done. We've actually what? Replaced each of them. Okay, so we can see that just above, this is the main diagonal here. Yeah. Okay, this one here, the one I've put in green, that's the main diagonal. So above the main diagonal and below the main diagonal, you can see they are all negative ones, right? Yeah. So there's a pattern that is developing there. Okay, so it means I'm done with this condition, I'm done with this condition. The one that is remaining, it said otherwise 0. So meaning that if it's any other condition, we are going to replace that entry with a 0. So all these other entries that have remained there, they're just simply zeros. Okay, they're just simply zeros because I've put what satisfies this and also added what satisfies this. So whatever is remaining, these are just zeros. So we're just going to erase them and put zeros. Okay, just going to erase them and put zeros. So here in this side, to be the same, erase them, we put zeros. Okay, so now let's put zeros. So 0 there, 0, 0, and then another 0, 0, 0, 0. This is 0, 0, and then 0. Okay, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, so that is our matrix A, and we've written it down explicitly. Okay, is it math amazing? Yes, it is. So that is our matrix A, okay? And then the other thing that they want us to do here, they're saying, show, okay, B, show that the matrix A is symmetric. Okay, show that the matrix A is symmetric. So there we have to recall the definition of what a symmetric matrix is. Okay, we have to recall the definition of what a symmetric matrix is. So first of all, let me reduce this guy. Okay, let me reduce this guy and then we have some space where we can show that A is actually symmetric. Okay, so that is my A there. I can erase so whatever I wrote there. Okay, and then now I have the privilege to make this smaller. Okay, so you can see our matrix A is there. Okay, this is our matrix A that we constructed. And then they said we should show that this matrix is orthogonal. It's symmetric. Okay, we want to show it if it's symmetric. So if it's matrix A is symmetric, okay, first of all, um, it has to be a square matrix. So we can already see this guy is a square matrix because the number of rows and columns are equal. And then now the second condition is that A transpose should be equals to what? To A. So we already have the matrix A, which we have written here. Okay, so we just have to find the transpose of A and then see if it's going to be the same as A. So A transpose. So what is a transpose? Okay, it just simply means you are writing the rows as the columns now, and then you're writing the columns as the rows. Okay, that's what it means to be symmetric. So let's see if I interchange the rows and the columns, the matrix that I'm going to get will still be equal to the matrix that I have there. Okay, so how do we do that? This is the first row. You can see, right? It has 2 minus 1, 0, 0, 0. So I'll write it as a column here. So it will be 2. Oh, what's happening now? It will be 2 minus 1 and then 4 zeros. Okay. The second row, this one here, I write it as a column now. So it will start minus 1, 2, okay, and then minus 1, and then the rest are zeros. The third row, I write it as a column here to be 0, minus 1, 2, minus 1, um, 0, and then 0. Okay. fourth row, I write it as a column here. It will be 0, 0, minus 1, 2, minus 1, and then 0. Fifth row, I write it as a fourth column here. To be 0, 0, 0, and then minus 1, minus 2. Oh, just 2, sorry. 2, and then minus 1. Okay, what about the sixth row? This one. I write it as a column now to be 0, 0, 0, 0, minus 1, and then 2. Okay, so let me erase this apart. So this is 2 there. Okay, and then this is my matrix. Okay, so now let's look at the matrix A and the matrix uh, A transpose. Are they the same? Okay, yes, they're the same. Okay, we can see that they are the same. So we just have to conclude now here. So you say since, okay, let me get the pencil. So you say since A transpose is equals to A, then A is symmetric. Okay, and we are done. All right, let's look at part C. So we've shown that it is indeed what? Symmetric. Okay, so now let's look at part C. So part C, they're saying compute A squared and describe the pattern of its entries. Okay, compute A squared and describe the pattern of its entries. So A squared, I know you know how to find that, right? Because A squared is just simply the matrix A multiplied by the matrix A. I know you know how to multiply the matrices. Okay, so my interest is here where they're saying describe the pattern of its entries. So how are you going to do that? Okay, so by describing the pattern of its entries, they want you to write that matrix that you're going to get in this form like that. That's what they mean, describe the pattern of its entries. Okay, they want you to write the A squared in terms of a piecewise function. So let's do that, see what we're going to get. Okay, so the A squared, it means I'm just multiplying A with A, right? So what I'm going to do here is this. I'm going to say this guy here, I copy it and then I multiply by itself. Okay, so let me just cancel this part. Okay, I delete this and then I'll just put it there. So I'm multiplying what? I'm multiplying this matrix with this matrix. Okay, this is A, this is A. So I get my A squared. So now, back in grade 12, we learned that when you are multiplying matrices, we just do, okay, we just do rows by what? By column. Then we had this symbol that uses us to, that we're using to remember. We're saying rows by columns. So this first row here has to multiply with all these columns there. Okay, this row has to multiply with all those columns there. This row has to multiply with all those columns. This row has to multiply with all those columns. This row has to multiply with all those columns. This row has to multiply with all those columns. And then we get our A squared. Okay, so I know you know how to do matrix multiplication. So I'll show you one example, and then the other ones, I'll just write them there. You can try them out at your own time. Okay, so let's start. So this is the first row. So it should multiply first column, second column, third column, fourth column, fifth column, sixth column. Okay, so 2 multiplied by 2. I'll get what? I'll get 2. Okay, and then I'll say minus 1 multiplied by minus 1. I'll get positive 1. So that will be plus 1. Okay, 0 multiplied by 0, 0. 0 multiplied by 0, 0, 0 and 0, 0, 0 and 0, 0. So what I get there will just be what now? Okay, what do I get there? Okay, so what did I do there? Said 2 multiplied by 2. Actually, that is 4, right? Why did I write why did I write 2? Okay, so 2 multiplied by 2, I get 4. Okay, and then minus 1 multiplied by minus 1, I get plus 1. So this is what I have there. Okay, so let's write the matrix somewhere there. Okay, so it means the first entry here, when I multiply the first row with the first column, I just get a 5. So I'm going to put the 5 there. Okay, that's what I have. Um, and then if I multiply this row with the second column, what do I get to get my second entry there? It will be 2 multiplied by minus 1, that will be minus 2, minus 1 multiplied by 2, that will be another minus 2. Okay, 0 multiplied by this minus 1, 0. 0 and 0, 0, 0 and 0, 0, 0 and 0, 0. So what I get there will just be a minus 4. So I'm going to say minus 4. Okay, that is my second entry in this matrix, A squared, like that. Okay, uh, let's move on and multiply the first row with the third column now. So 2 multiplied by 0, I get 0. Minus 1 multiplied by minus 1, I get plus 1. 0 multiplied by 2, 0. 0 and 0, 0. So the rest will just be zeros. So meaning that I'm just going to have a 1 there. Okay, I'm just going to have a 1 there. What is remaining now? Okay, what is remaining now? So now I'm multiplying the first row with the fourth column. Okay, this first row with the fourth column here. So 2 with the 0, 0, minus 1 with the 0, 0. And then I only remaining with the 0. So it will multiply this and it will just be 0. So the fourth entry will be 0. Fifth entry, it will be first row, fifth column. So 0, I mean 2 multiplied by 0, 0, minus 1 multiplied by 0, 0. 0 multiplied by everything here, just be 0, because I'm only remaining with the zeros there. So that will be 0 as my fifth entry. I'm remaining with 1. So that is the first row here multiplied by the sixth column. So 2 multiplied by 0, 0, minus 1 multiplied by 0, 0. Then 0 multiplied by 0, 0 multiplied by 0, 0 multiplied by minus 1, 0, 0 multiplied by 2, 0. So I also get what? 0. Okay, so that is what I get there. Okay, that's what I get there. Um, and then for you to find now the elements of the second row, you do the same. So you start multiplying now. This row here, seen this row here, you multiply with the first column to get the element there. Multiply this with the second column to get the element there. Multiply this with the third column to get the elements there. Okay, just basic normal matrix multiplication there. So you should try that out, but I'm just going to write the final answer that I got. Okay, so after doing the calculations, I found that the elements of this matrix, the other ones that I here, I'll be having minus 4, 6, minus 4 again, and then 1, 0, 0. The third row had 1, minus 4, 6, then minus 4, 1, and then 0. The the fourth row had a 0, 1, minus 4, 6, minus 4, and then 1. The fifth row had a 0, 0, 1, 0, 0, 1, and then minus 4. Okay, and then I had a 6 there, and then a minus 4. Okay, and then the sixth row, can you extend this? Okay, the sixth row had 0, 0, 0, 1, and then minus 4 with the 5 there. Okay, so make sure you try to compute and see if you get the exact value that I got. But I show you how to do the calculations, right, with this first row. Okay, so this was the matrix that I got as my A squared. Okay, that was the matrix that I got as my A squared. So now the other question was to describe the pattern of these entries for the A squared. Okay, so what can we see there? And then we describe it. Okay, so I earlier said by description, okay, you can just easily express this in a piecewise function like that. Okay, so what we can see from here is that the main diagonal has 5 at the ends and then 6 in the middle. So you can see there's 5 there, there's 5, and then the rest that are in the middle, these are just 6. Okay, so identifying the pattern. And then first off diagonals are -4. So this is the main diagonal, right? Okay, so first off diagonal, we mean if I go to the right, I mean, if I go above the main diagonal, or if I go below the main diagonal, you can see I'm finding -4, -4, -4. If I go on top of the main diagonal, again, I'm finding -4, -4. Okay, so the first off from the main diagonal is a -4, and then the second off from the main diagonals are just 1. So this is the main diagonal here. So the second off, it means we move 2 steps above or below. So one step, I go to the -4, and then the other step, I go to the ones, 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 like that. And even here, if I do 2 steps, I'll find the ones like that. Okay, so the pattern there is that the second off entries from the main diagonal are actually ones, and then all the others that are remaining are actually a 1. So that's a very easy pattern to identify. Okay, so I'm going to write this now in terms of a piecewise function. So let me just create some space there. Okay, so I'm going to say a squared is equals to the matrix B ij. Okay, or you can choose any data of your choice here. So this Bij will be equals to, okay, the matrix A squared is equals to Bij, okay, where, or defined by, okay, I'll just say defined by so that I'm consistent with that they use. Defined by Bij is equals to, then I form a piecewise function. So what I see there is that it is 5, okay, if I is equals to j, but it's specific for those i's and j. It's only a 5 if I is equals to 1, or if I is equals to what? To 6. That's what you can see. Because here, this is the first row. My I is the 1. This is the fifth row. My I here is 6. So if my I is 6 or my I is 1, I'm going to get my entry there as just 5. Okay, and then it will be 6 if I is equals to j, okay, and this I is between 2 and -5. Okay, so from 2 to -5, and if the I is equals to j, I'll be getting 6, these elements there. Okay, so that's the pattern I can see. The other one is the ones that where we have the -4s. So the -4s, we describe them as the first of the main diagonal. So meaning if I subtract the I and the j, or the j and the I, I'm going to get a 1 because they're just first off from the main diagonal here, the -4s, these ones. So I'm going to say I get a -4 if the modulus of I minus j is equals to 1. So you can try this. Okay, so if, for example, if this entry here is what? It's in the second row, first column. So my I is 2, okay, minus my column is 1. Then I get the modulus of this, I'm just going to get 1. And you can see it's -4. So the pattern repeats for all these and for all those. Okay, and then the other thing that I can see is that I have a 1 if, okay, I am 2 steps from the main diagonal. So meaning if I have I minus j, modulus being equals to 2, then I'm just going to get 1 or 1 there. So let's try on this element here. So it's in the first row, third column, right? Okay, so the I is 1 minus, the column is 3, modulus. This is just going to give me -2, which will just be a +2. So whenever the answer is +2 like this, it means the answer there should be a 1. So you can try for these others here, you're still going to get the same thing. And then the other one is the last one where we're going to say 0 otherwise. Okay, so all the other conditions, they're just going to give you a 0. Okay, so that's what we have there. So I can move this a bit up like that so that we see clearly what we've written there. Then I move this a bit up as well. Okay, so we said it's 0 otherwise. So I can write the 0 nice now. 0 otherwise. Okay, and then I will put this to my brackets like that. Yeah, so this is the pattern of its entries. This matrix A squared that we found. Okay, so that's simply how we can answer this question there. All right, so welcome to this video. In this video, we are going to be looking at polynomials of a matrix. Okay. All right, so the question says, given matrix A is equals to 3, 1, 2, 1, and let P1 be equals to x squared minus 16, P2 is equals to x plus 4, P3 is equals to x minus 4. Show that P1 of A is equals to P2 of A multiplied by P3 of A. Okay, so this is where we are converting a polynomial, okay, into a matrix polynomial. Okay, so look at what we've been given here. These are polynomials here. Okay, this is a quadratic, this is a linear, this is a linear. So they are polynomials. Okay, so we've been asked to show that P1 of A is actually equals to P2 of A multiplied by P3 of A. So this is what we want to show here. So how are we going to do that? Okay, we're just going to get the P1 here, and then wherever there's X, we're going to replace with the matrix that we can see there. Okay, so that one is going to be, using this one for the P1, it's going to be, wherever there's X, I'm now putting the A. So it will be A squared minus 16 is equals to, this is P2 of A. So wherever there's X in P2, I put A. So that is A plus 4, okay? And then this one, this is P3 of A. So wherever there's X, I put A, then minus 4. So this is what I have, okay? So you notice that here I have A squared minus, I have A squared minus 16. Okay, so this A here is a matrix. You can see it there. And then this is a constant 16. So we can subtract a matrix and a constant. So what do we do? Okay, we always make the constant, or in short, we turn the constant into a matrix. So how do we do that? Okay, we multiply this constant by the identity, matrix, okay, with the same order as the matrix that was given. So this matrix here, we can see we have 2 rows and we have 2 columns. So its order is 2 by 2. So I'm going to multiply this 16, okay, by the identity element with the same order as this. So this will be, now I'll replace this A with the matrix. So that will be 3, 1, 2, 1. Okay, and since it's squared, so it means it's multiplying itself. Okay, so this is what we have. And then minus this 16 here will be 16. Okay, and then I'll multiply by the identity, which is a 2 by 2. So that will just be 1, 0, 0, 1. So the identity just has ones in the main diagonal there. So this should be equals to A, which is 3, 1, 2, 1, okay, plus 4. So that plus 4, 4 is a constant, so I also turn it into a matrix by multiplying by the what? The identity. So it will be 4, and then I put the identity there. So that I turn the 4 into a what? Into a matrix. Okay, so let's move this a bit. Okay, so we still have this whole thing here multiplying by whatever we have there. So this one has to be in brackets like this. It represents the A plus 4. And then the other thing that I have now is, okay, I have A, which is 3, 1, 2, 1. Okay, let me write that 3, 1, 2, 1. Okay, minus 4. And then I put the identity because there's 4 there, which is a constant. So that is 1, 0, 0, 1, like that. Okay, and then I can close the brackets like that. So I want to show that these two sides are actually equal. So here, I'm multiplying here. So what am I going to do? I'm going to multiply row by column. So 3 multiplied by 3, that would be 9. 1 multiplied by 2, that would be plus 2. And then 3 multiplied by 1, that would be 3. 1 multiplied by 1, that would be plus 1. Okay, I come to this row, I'm multiplying by the first column. So that would be 2 multiplied by 3, that would be 6, plus 1 multiplied by 2, that would be 2. Okay, and then 2 multiplied by 1, that would be 2. 1 multiplied by 1, that would be plus 1. Okay, so this is what we have here. Then minus. Here I'm going to multiply the 16 throughout. So that would be 16, 0, 0, 16. Okay, what about here? Before we even go to the other side, I can combine this. So this will be 11 here, 4 there, 8 here, and then 3. So I'm going to write those numbers there. Okay, so once we add, we get 11 here, 4 there, 8, and then 3. Okay, so what about on my right-hand side here? So this one here, we can clearly see that when I multiply this 4 with whatever I have here, okay, what do I have? I just have 4 there, 4 there, and then 0, 0. So I can say this guy here is, okay, I multiply with the 4. So this one goes, this one goes. I now have a 4 there and a 4 there. So I'm adding here. I'm adding two matrices. So we add entry by entry. So it will be 3 plus 4. Okay, 3 plus 4, it will give me 7. And then 1 plus 0, that will just be 1. Okay, and then 2 plus 0, that will be 2. And then 1 plus 4, okay, 1 plus 4, that will be 5. And then I'm multiplying this by the uh, answer that I get in these brackets here. So again, this 4 is going to multiply that 1 and this 1. So I have 4 there and 4 there. So meaning that this 4 here disappears, this one becomes 4, and that one becomes 4. So let's write them as here I have 4, here I have 4. So 3, okay, 3 minus 4, that is minus 1. 0, 3 minus 4, that is minus 1, and then 1 minus 0, that's simply 1. And then 2 minus 0, that would be 2, and then 1 minus 4, that would be minus 3. Okay, that would be minus 3. So that's what I put there. Okay, so let's multiply here and let's subtract here. So here it will be 11, okay, minus 16. So 11 minus 16, it gives me a minus 5. 4 minus 0, that's still 4. 8 minus 0, that's 8. And then 3 minus 16, that is minus 13. So this should be equal to, here I'm multiplying. So 7 multiplied by this, okay? I get 7 multiplied by minus 1, I get minus 7. And then 1 multiplied by 2, I get plus 2. 7 multiplied by 1, I get 7. 1 multiplied by minus 3, I get minus 3. 2 multiplied by minus 1, I get minus 2. And then 5 multiplied by 2, I get plus 10. 2 multiplied by 1, I get 2. 5 multiplied by 3, I get minus 15. So you see that this guy here, okay, here I'm just going to have minus 5 when I combine this. Here I'm going to have 4. Here I'm going to have 8. Here I'm going to have minus 13. So we see that the left-hand side is actually equal to the what? The right-hand side. Okay, so we are going to say hence shown. Okay, hence shown. And that's all for this video. Okay, thank you for watching. This has been Tutor Pro Solutions. Bye-bye. All right, so now let's look at this question here that will test our knowledge on the inverse, okay, or the invertibility of a matrix. Okay, so if we say a matrix is invertible, what does it mean? So this question will test our knowledge of that. Okay, so if I have a matrix A, and then I'm told this matrix A is invertible, okay? If I have the matrix A and then I'm told this matrix A is invertible, then it means that this matrix A has an inverse A to the power minus 1 like that. So this simply means inverse of A. So we indicate it here, a to the power minus 1. So if they say A is invertible, then they mean there exists an inverse to this matrix A. Okay, so now a special property is that when I multiply the matrix A with its inverse, okay, or if I multiply the A inverse with A, I always get the identity matrix. Okay, I always get the identity matrix. So if you multiply a matrix by its inverse, you get the identity. Okay, so if I was to say it in just simple numbers, if I multiply 10 with its inverse, so the inverse of 10 is 1 over 10. This is the inverse of 10, right? So when I multiply this, I just get a 1, right? Okay, because I've multiplied with the inverse. So I just get 1 there. So now in terms of the matrices, the 1 of the matrix is just the identity matrix of the same order of the matrix that you are considering. Okay, so no wonder here you're saying A multiplied by its inverse, I get the identity of the same order as this matrix, what? A. Another property that we should know is that if I multiply any matrix, let's say A, with the identity, I always get back the matrix itself. If I also do A inverse multiplied by the identity, I'll just simply get A inverse. So the identity, if you're multiplying it with something, it has no effect. It's the same as 1. If I get 10 multiplied by 1, I'll just get 10. 5 multiplied by 1, I'll just get 5. So this guy here is an identity, okay, for these numbers there. So it's called the multiplicative identity, this one. If you multiply it with any number, you're still going to get that number. So it's the same when now we're talking about matrices. If I multiply a matrix by an identity matrix with a similar order that it has, not in fact similar, but the same order that it has, then I'm just going to get that same matrix. Okay, so understand this concept because they're the ones that are going to help us understand or solve this question here. So here they're saying let A be an invertible matrix satisfying the equation A squared plus 4A plus 5I, this I means identity, right, is equals to 0. Okay, so the first question here is express A inverse as a polynomial in A. So in short, they want us to make A inverse to be the subject of the formula for this equation. So what can we do? We use this property here. Okay, we use this property here. So A squared is the same as I write A multiplied by A, right? And then plus 4A, okay, and then plus 5I is equals to 0. So A and A are matrices. A is a matrix, and this I is also a matrix. 4 and 5, those are just constant. Okay, so what I'm going to do is that I'm going to multiply throughout by A inverse like that. So if I multiply by A inverse, I'll have A inverse A, and then A again, plus, this is a constant, so I can get the A complement, the A inverse, and just put it in front of the A. So it will be 4 A inverse and then A, plus, again, this is a constant, so I can write 5 A inverse and then I. Okay, so why am I emphasizing that this is a constant? Because if this was a matrix, then we can't put the A inverse just between those. Okay, we will have to put it in front here. Okay, because matrices, their multiplication is not commutative. All right, so and then if I multiply this with a 0, I'll just get 0. Okay, so now based on these rules here, we said A inverse with A just gives me the what? The identity. So this is the identity with A plus 4, and this again will be the identity like that. Okay, and then what do we have here? Here we have the inverse with the identity. So if you're multiplying anything with the identity, you just get that same thing. So that would be 5 A inverse is equals to 0. Okay, inverse multiplied by the, A multiplied by the identity, I get A plus 4 inverse, 4 identity plus 5A inverse is equals to 0. So what I'm going to do now is that I'll take everything that does not have A inverse to the right-hand side. So I'm going to have 5 A inverse is equals to, okay, is equals to minus A minus 4I. Okay, so remember is to express A inverse as a polynomial of A. So I have to make this A inverse to be the subject. So I'll divide throughout by a 5, or I'll multiply throughout by a minus 5. Okay, so what am I going to get? I'm just going to get that A inverse is the same as, okay, A inverse is the same as minus 1 over 5 multiplied by A, and then minus 4 over 5 multiplied by the identity like that. So you can see that A inverse is actually the subject of the formula here. So we are done with part A. We have expressed A inverse as a polynomial in A. Okay, so that's what we've done there. All right, the other question now says what? Okay, so the other question says, show that A commutes with A inverse. So if A and A inverse commute, then it means that if I multiply A with A inverse, I should get the same answer as when I multiply A inverse with A. That's what it means to commute. Okay, simply meaning that order doesn't matter. If you start with A or you start with A inverse, you're still going to get the same answer. So if that gives us the same answer, then we're going to conclude that A actually commutes with what? A inverse. So let's first find A multiplied by A inverse. So A multiplied by the A inverse, I'm just going to say this is equals to, I keep the A, and then what is my A inverse? A inverse is this thing here. So that would be minus 1 over 5 A minus 4 over 5 I, okay? Expand the A, I'll have minus 1 over 5 A squared, then minus 4 over 5, and this one here will just be A multiplied by the identity. It will just be A. Okay, what about if I do A inverse multiplied by A? What am I going to get as my uh, my answer? Okay, so again, I'll just replace the A inverse with minus 1 over 5A minus 4 over 5 identity, and then multiply by the A, which is outside there. So A. So this will just be equals to, I just distribute this A inside there. So it will be minus 1 over 5A squared minus 4 over 5 A multiplied by the identity. I just get what? A. Okay, so are these two the same? You can see that yes, they're the same. Okay, so you can conclude now. Okay, so you say since A multiplied by A inverse is equals to A inverse multiplied by A, okay, then A commutes with A inverse. Okay, A commutes with the A inverse like that. And we are done. Okay, we're done this question. All right, so welcome to this video. In this video, we're going to be looking at some properties of the transpose of a matrix, as well as what symmetric matrices are, as well as what are skew symmetric matrices. Okay, so we'll use this question to help us understand. But first of all, let's define what a transpose is and also talk about the properties of a transpose. Okay, so a transpose, okay, I'll say if A is, okay, an M by N matrix, okay, if A is an M by N matrix, then its transpose, denoted by A transpose, okay, is um, an N by M matrix. So what do we see here? Okay, we see that we have just interchanged the rows and the column. So here, this is what we call as the order of the matrix. So it's obtained by multiplying the number of rows multiplied by the what? The columns. Okay, so here, the number of rows are M, the number of columns are N. But in the transpose, we interchange. Okay, so the number of rows now here are N, and then the number of columns are what? M. So for example, if my matrix A, okay, is 5, 10, 1, 2. Okay, if this is my matrix here, so it means that my A transpose is going to be equals to, I'll write my rows as my columns. So that will be 5, 10. Then this one is the second row. So I write it as the second column. It will be 1, 2. So you've seen that we've actually interchanged the rows and the columns. So that's what a transpose is. Okay. So you also have to know some important properties of a transpose. Okay. So for example, if I have matrix A plus matrix B and then transpose, this is the same as A transpose, okay, plus B transpose. So you simply distribute the transpose to the matrices in the brackets. Okay. If you're subtracting matrices, the rule is going to work in a similar way. So it will just be A transpose minus B transpose. Okay, so the other one, which is very important because they like bringing questions around it, is the transpose of a product of two matrices like this. Okay, so if you have two matrices like A and B, okay, and then you are taking their transpose, the answer will never be B. Uh, the answer will never be A transpose, B transpose. No, this is wrong. Okay, so never do this here. So the answer will always be the conjugated product of whatever you had here. So by conjugate, we mean that we're not going to start with A here. Okay, instead, we are going to start with the second matrix, which is B. So this is the same as B transpose and then A transpose. Okay, why? Because when you're multiplying matrices, okay, AB will never be equals to BA. Unless A and B are equal matrices, then they will be equal. But as long as A and B are not equal, okay, then A multiplied by B will never be equals to B multiplied by what? A. Okay, so this one here is the correct way of applying the transpose to a product of what? Matrices. Okay, what about if I have A, okay, and then I have A transpose outside. Okay, how can I handle this? So this is still a product of two matrices. So I handle it the same way I've handled this. Okay, so meaning the second matrix is the one that I start with. So that will be A transpose, okay, with a transpose that was outside here, and then this A with a transpose. So now this leads to another rule that I was supposed to talk about. So if you have A transpose transpose, the transposes cancels out. So you just remain with A there, and then this remains A transpose. Okay, so that's what we have there. Okay, that's what we have there. So the transpose first goes to this guy, okay, which is A transpose. So you have that, and then it goes to the A, so you have A transpose like that. Okay, and then if I have A transpose, and then transpose, the transposes cancels out, so we just remain with A. Okay, so what other rule can I talk about? The other rule is when you are transposing something that has a constant in front. So if there's this constant in front, like any number like 2, maybe 4, 5, it's multiplying a matrix, and then you're taking the transpose. This transpose will not affect the constant. Okay, so the constant remains intact, and then the A receives the transpose. Or in short, okay, the transpose of a constant, it's the constant itself. So I'm writing the K again there. So take note of these properties. They'll be very important as we'll be solving whatever we'll be solving here. Okay, so now let's define what the symmetric matrix is. Okay, so if, for example, I have a matrix P, okay, we're going to say this matrix P is symmetric if if P transpose is equals to P. So if I take the transpose of this matrix P and is still equals to the matrix P, then we are going to say the matrix P is symmetric. Okay, and then I'm going to say the matrix P is skew symmetric, okay, if P transpose is equals to minus P. So take note. So this is just symmetric. This is skew symmetric. Okay, so those are the definitions there of symmetric and skew symmetric. So now let's solve this question now with confidence. So they're saying, show that if B is a square matrix, okay, then B multiplied by B transpose and B plus B transpose are symmetric matrices. Okay, so what are we going to do there? The first thing we're going to say, let P be equals to B and then B transpose. Okay, so if this guy here is symmetric, then we expect that P transpose should be equal to what? To P. Okay, so we already have P. So we just have to find P transpose. So I'm going to say, okay, P is equals to B multiplied by B transpose. And then now I'm going to apply the transpose on both sides. So transpose here and transpose there. So here I'll just have P transpose is equals to, and then here, remember this is a product, okay, of two matrices. So how do we apply the transpose? We start with the last matrix there. So it will be B transpose with the transpose outside, which one? Okay, and then this one now goes to the B, so that will be B transpose. So we know that B transpose transpose, that is just B, and then this one remains B transpose. Okay, so what can we see there? We can clearly see that P transpose is equals to B transpose, okay, which is the same as P. Because initially we had said P is this, and then we are finding that P transpose is also equals to this. So P is equals to what? P transpose. So that makes the BT to be what? To be symmetric. Okay, because they are equal. So the P and the P transpose are equal. It means the P is symmetric, but P is equals to BT. Okay, so that makes also this BB transpose to be what? Symmetric. Okay, so let's take a look at the other one. So the other one was saying we show that B plus B transpose are symmetric. So there we're going to say let P be equals to B plus B transpose. Okay, so now we try to find the transpose of this P. So P transpose simply meaning I'm also taking the transpose the other side, right? So it will be B plus B transpose and then transpose. So we said by the properties, we can distribute this transpose to whatever is inside. So it goes to the B, so it will be B transpose. And then here it goes to this transpose, so they cancel out. So that will be plus B. Okay, but this is addition here. And we know that addition is actually commutative. So for example, 5 plus 1 is equals to 6. Again, if I say 1 plus 5, it still gives me 6. Okay, so when adding, the order doesn't matter. So this one here, B transpose plus B, is actually the same as B plus what? B transpose. Okay, so what does that tell us? Okay, it tells us that the P is equals to this. Okay, and I can also clearly see that the P transpose is equals to what? The same thing. So P transpose is equals to P, which is just equals to B plus B transpose. Okay, so this proves or shows that the B plus B transpose there is actually symmetric. All right, let's look at the skew symmetric. Okay, so skew symmetric, remember the definition we said if P transpose is equals to minus P, then we're going to say P is skew symmetric, right? So the process is the same. So we're going to say let P be equals to B minus B transpose. So from this expression, I'll get my P transpose and my minus P. Okay, so let's start with the transpose. So if I say P transpose, it will be equals to, I have to put the transpose even on the other side. So it will be B minus B transpose and then transpose. So the transpose goes to the B, I have B minus, I have B transpose, I mean. Then the transpose goes to the B transpose, I just have B. So my P transpose is B transpose minus B. So you keep this, and then now you find the minus P. So minus P simply saying whatever is on this side, I also multiplied by a negative because I've multiplied the P by a negative. So it will be minus and then B minus B transpose. So this will just be equals to minus B plus B transpose. Then I can start with the positive one. So that would be B transpose minus what? B. Okay, so that is my minus P. So you've seen now that the P transpose is equals to minus P, which is equals to B transpose minus what? B. So this proves, okay, that this expression here is actually what? Skew symmetric. Okay, so we're going to say hence shown. Okay, so we found or shown whatever they were asking us to do there. Right, so thank you so much for watching. This has been Tutor Pro Solutions. Until next time, bye-bye. All right, so welcome to this video. This video will help us understand the concept of commutativity of two matrices. Okay, so if I have been given two matrices, let's say A and matrix B, okay, I would say these two matrices are commutative, okay, if A multiplied by B is actually the same as B multiplied by A. So this is the commutativity property, meaning whatever you start with actually does not matter. So if you have two matrices that obey such, then we're going to say those two matrices are what? Are commutative. Okay, so now let's look at this question here. So they're saying, let A and B be n by n matrices. Okay, so n by n simply meaning they're square matrices, such that A and B is equals to B and A. So this simply tells us that A commutes with B. Okay, A commutes with B. As simple as that. So now, part A. Prove that A plus B squared is the same as A power 3 plus 3A squared multiplied by B plus 3A B squared plus B to the power 3. Okay, so we want to prove that this is true given that A commutes with what? With B. Okay, so what we need to do is just expand. So I'll start with the left-hand side. So I'll say A plus B, the power 3 is the same as A plus B, A plus B, and then A plus B as well. So they are multiplying themselves by 3. Okay, let's start with the first one. So A multiplied by A, I get A squared. A with the B, I get AB. B with the A, I get plus BA. And then B with the B, I get plus B squared. That's what I have in brackets. And then there I still have my A plus B. Okay, so now when I look at inside the brackets there, they've said A multiplied by B, B multiplied by A. But we were told these things here are actually what? They're actually equal. Okay, they're actually equal there. So I'm just going to replace this with AB since it's equals to the AB. So I have two ABs there. So it's just going to be A squared plus 2AB, then plus B squared multiplied by A plus B. Okay, so now we expand. A multiplies with everything here. So it will be A to the power 3 plus, okay, remember it's multiplying from the right-hand side. So whatever I'm multiplying with should come to the right. So this one here becomes 2AB with the A that is multiplying. So I write A. And then the A here, it will just be plus B squared and then A. Okay, again, I multiply with the B. It will be to the right. So it will be plus B with this. It will be A squared, then B. B with the 2AB, it will be plus 2AB squared. Then B with the B to be plus B to the power 3. Okay, so remember our goal is to have something like that. Okay, so here I have A squared B, then here I have AB squared. Okay, so can I see any term that has a squared and then b? Yes, I can see that term. So look at this term here. It has a squared b. And here there's also a squared b. Okay, so I just have to make one of these others to be a squared b, then I'll be good to go. Okay, so let's take a look at this. You've seen this guy here. I'll write him here. 2a, b, and then a. So remember, we were told that ab is equals to ba. Okay, so I'll write the first a, and then this ba here, since it's equals to ab, I'm going to write in place of it, I'll write instead the AB because they are equal. So this AB here is equals to, BA here is equals to AB. So where there's BA, I can replace with what? AB. So what I have there will just be what? 2. Since these are the same, it will be A squared and then B. Okay? So meaning that what I have now is A to the power 3 plus this guy here has become 2A squared B. Okay, and then I will bring this closer. So plus a squared b. Okay, so the other thing that we saw in this equation was the ab squared. Okay, so where can I see ab squared? I can see ab squared there. So I just have to make this guy here also to be ab squared, this guy here. So I'll get this guy. So it is a b squared and then a. So b squared and then a is the same as b multiplied by b and then a. Okay, so now since a commutes with b, I can replace ba with ab. Okay, so I'm going to write b, and then this ba here, I'll replace it with ab. Okay, so I'll just write a and then b. Okay, and then again, since ab is equals to ba, I can replace this ab here with I can replace this BA here with AB. So I write A and then B, and then this B is there. Okay, so meaning here I just have A, and then this is BB. So this will be B what? Squared. Okay, so this guy is already there. So I'll just add it here. So it will be plus 2AB squared. And then this guy here, oh, where is it? This guy here, I've transformed this from this to AB squared. Okay, so I'll just put plus AB squared and then plus what we have now, the B to the power 3. Okay, so our equation is almost coming out. So I hope you followed here because I'm going to erase on top there. So meaning that what we have is just what now? Okay, maybe I should not erase. So let me just try to move it above. Okay, let me try to move it above. Okay, so I have like a space down there to write the last statement. So this will be equals to a to the power 3 plus this and this are the same. And here we have 2, here we have 1. So this will be 3a squared b plus this and this are the same. So that will be 3ab squared plus this will just be b to the power 3. And we can see that's exactly what we are told to prove. Okay, that this is actually equals to this, what we have in the question. So you say hence proved. Okay, hence proved. And you're done with part A. When you look at part B, so I'll erase this now. When you look at part B, they're saying, give an example of A and B for which this identity fails. So this identity can only fail if A, B is not equal to BA. So I'm just going to look for two simple matrices such that if I get the product of AB and B, they're not going to be commutative, then it will fail. Okay, so I'm going to say, okay, let A be equals to, so you get any, as long as it will fail. So 0, 0, 1, 0, and then let my B be equals to 0, 1, 0, 0, like that. Okay, so you see that if I do A multiplied by B. It's going to give me what? 0. Remember, it's row by column. So 0 multiplied by 0, 0. 1 multiplied by 1, 1. So I get 1. Then 0 multiplied by 0 plus 1 multiplied by 0, I get 0. 0 multiplied by 0, 0. 0 multiplied by 0, I get 0. 0 with the 0, 0 with the 0, I get 0. So this is my AB. Okay. What about if now I want to find my BA? So let me write the A in front here. So this is my A. So now I'm finding BA. Is it going to be the same? Okay. So immediately you have A, B not being equal to BA, then those are the two matrices that you can use because it means the commutative rule there has actually what? Has actually failed. So let's do. So 0 with the 0 plus 0 with the 0, I get 0. Already this is not equal because here there's 1, here there's 0. 0 with the 1, 0, 0 with the 0, 0. 1 with the 0 plus 0 with the 0, 0. 1 with the 1, 1, 0 with the 0, 1. Okay, so we can clearly see here that AB is not equal to BA. So meaning that A does not commute. Okay, A does not commute with B. So if A does not commute with B, it means this will not be possible here. Okay, and if this is not possible, then uh, this identity there actually fails. Okay, so that's how we can answer that question there, and we are done. All right, so welcome to this video. In this video, we're going to look at how we can use some of the properties of matrix, some of the properties of matrix operations. Okay. All right, so we have this question to help us with this concept. So they're saying, let A and B be matrices of appropriate orders. Show that A plus B squared is not equal to A squared plus 2AB plus B squared in general, and give a condition when A plus B squared is equals A plus B squared will be equals to A squared plus 2A plus B squared. Okay, so let's discuss some of the properties, okay, of matrix operations. Okay, so the first one is the one that involves addition. So we are saying that A, okay, if A is a matrix and B is a matrix, then A plus B, this is the same as B plus A. Okay, so in short, we are saying addition of matrices is commutative. Okay, then the other one is that if I have three matrices, A, B, and C, then A plus B plus C with the B and C in brackets is the same as A plus B in the brackets plus C. Okay, so it doesn't matter which expression is in the brackets, it's still going to give you the same answer. So this one here, we say that's the property for associativity. So addition of matrices is associative. Okay, what about multiplying by a constant? Okay, so for example, I have two constants, let's say D and K, multiplying matrix A. This here is the same as D multiplying K multiplying A, which is also the same as K multiplying D and A. So in short, you can factorize the constant. There's no problem. Okay, so these are very important properties. Okay, they look simple here, but when you'll be using them in most of the questions, they're going to be like confusing. So you better understand them from here. So the other property is that if I have a constant outside A plus B, then I can simply distribute the constant to the A and B. So that will just be KA plus KB. So this is called the distribution property. I can distribute a constant over the summation of two matrices. The other one, okay, that I want you to pay attention to is that A, okay, multiplied by BC in brackets, okay, is the same as AB multiplied by C. Okay, so this is only true when you're multiplying three matrices and then you put two of them in the brackets. So this is also true. So multiplication of three matrices is associative. Okay, and then the other one is also distributed. The distributive property for three matrices. So mean I have A plus B plus C. This is the same as AB and then plus AC. Okay, so now the most important property that we're going to use in this question here is the one that says that AB, okay, which is the multiplication of matrices, is the same as, is not the same as BA. Okay, so AB, okay, when you multiply AB and you multiply BA, they are not the same. Okay, they're not the same. So, for example, if A is equals to, let's say 1, um, 0, and then, okay, let me put 1, 2, and then 0, uh, let's say 3. And then if my B is equals to, let's say 2, 1, minus 1, and then 0. Okay, so if I find AB here, if I multiply A and B, it won't be the same as when I multiply BA. Okay, so AB will just be equals to, okay, so let's try to prove it. So AB will be equals to 1 multiplied by 2, that will be 2. Okay, and then 0 multiplied by this, that will be 0. So here I'll just have 2. 1 multiplied by 1, that will be 1. 0 multiplied by this, that will be 0. So I'll just write 1 there. Okay, what about 2 multiplied by 2? That will be 4. And then 3 multiplied by minus 1, that will be minus 3. So that is 4 minus 3, that will be 1. And then 2 multiplied by this, that will be 2. And then 3 multiplied by 0, that will just be 0. So I have 2. So if you've seen from these two matrices, I've gotten my AB as this. So let me find my BA. Okay, so BA, it means I'm multiplying now this with the A. So I'm starting with the B. So the B is 2, 1, minus 1, 0. And then the A is 1, 0, 2, 3. So if I multiply this, what do I get? 2 multiplied by this, I get 2. Okay, and then 1 multiplied by 2, I get 2 again. So if I add those, I have 4. 2 multiplied by 0, 0. 3 multiplied by 1 multiplied by 3, that will just be 3. Minus 1 multiplied by 1, I get minus 1. Okay, and then 0 multiplied by these 2, it's 0. So here I have minus 1. Then minus 1 multiplied by 0, 0. 0 multiplied by 3 is 0. Okay, so now look at AB and BA. Okay, but they are the same matrices that we have, but their answers are what? Different. So this is the rule that should be in your heart. Okay, you have to know it. Okay, so AB will never be equals to BA as long as the two matrices are not the same. Okay, it can only be possible if the two matrices are actually the same matrix. Okay, so now using that property, we're going to prove whatever they were asking here. So I thought it was wise to explain the property. So here they're saying, let A and B be matrices of appropriate orders, meaning we can multiply them. Show that this is not equal to this. So what do I do here? I'm just going to expand whatever I have on my left. So this guy here is the same as A plus B multiplied by A plus B, which will just give me A multiplied by A, that will be A squared. A multiplied by B, that will be AB. And then B multiplied by A, that will be BA. Okay. And then this is what now? This is A multiplied by, B multiplied by B, that will be B squared. Okay, so what we have here is A squared plus AB plus BA. Okay, plus B squared. So we see that A plus B is actually equal to what? A squared plus AB plus BA plus B squared. Okay, so when you look at the two terms that are in the middle here, there is AB and BA. And from the properties, we say these cannot be equal, okay, if B and A are different matrices. So they can only be equal if there's one and the same matrix. Okay, so in general, when A and B is not equal, then this A plus B squared will be equals to this. okay, and not the expression that they gave us there. Okay, so we can see that A plus B, okay, is equals to this, which is not equal to whatever they gave us there, which is A squared plus 2AB plus B squared. Okay, so we are going to say by this property, okay, that AB is not equal to BA, this A plus B squared is not equal to A squared plus 2AB plus B squared. So hence shown. Okay, hence shown. All right, and then now they were further going on to say, give a condition when this is equals to this. So this can only be equal to this, okay, if A is equals to B. Okay, so if A is equals to B, then AB is going to be equals to what? To BA. So meaning that in this my equation here, I can replace the BA with AB because they are equal. So I'm just going to write A plus B squared is equals to A squared plus AB. Okay, but remember we said AB is equals to BA. So this BA here, I'll replace it with another AB plus B squared, which will just be equals to A squared plus 2AB plus B squared. So the only way, okay, or the only condition that is required for this statement here to be true, okay, is when the matrix A is equals to B. So when matrix A is equals to B, it means that the product AB will be equals to what? BA. And in the end, we're going to get what we have gotten there. Okay, so that's how we can show it, and that's how we can give the condition that is necessary for that uh, identity to be true. All right, so thank you so much for watching. This has been Tutor Post Solutions. Until next time, bye-bye. Okay, so now let's look at the question on symmetric matrices. Okay, so a matrix A, okay, is symmetric, one, if it is a square matrix, okay, and the following condition is met, A transpose is equals to A. Or if we are considering a matrix B, we're going to say this matrix is symmetric if one, it is a square matrix, and then B transpose is simply equals to the matrix itself. Okay, so now here they're saying suppose A and B are symmetric matrices. Okay, so meaning these conditions hold, show that A, B, A is what? Is symmetric as well. Okay, show that this is symmetric. So what do they mean here? Okay, they just want us to show that the transpose of ABA is equals to ABA. So if we wanted to show this, then we're going to conclude that this guy here is actually what? Symmetric. Okay, so now there's an important thing that you have to know here, and that is the transpose of a product. So, for example, if I have, okay, if I have xy to the power 2, okay, xy to the power 2, and then I want to distribute this power. I'll just say the 2 goes to the x, so I have x power 2, and then 2 goes to the y, so I have y power 2, right? Okay, so now when you're talking about the transpose, this thing here won't work. Okay, so for example, if I have x, y, and then outside I have a transpose. If you expand this such that you have x, and then the transpose goes to the x, then y, and then the transpose goes to the y, this here is a no. Okay, it's a no, it's wrong. So these things here are not equal. So simply meaning that the transpose of a product, okay, is not equal to the product of their individual products. Okay, no, it's not equal to that. So the transpose of a product, if I say I have a matrix X and Y, and then I say transpose, this here should be equals to the commutated product of the individual products. So what do you mean? It means we start with the Y transpose and then the X transpose. Okay, this is correct now. So whenever you have a transpose outside and then you have a product inside, you first distribute the product to the last matrix and then go to the other one. If there are three, and then go to the other one. So you write the last one first, and then the one that follows just like that. Okay, so this is what we call as the commutated product of a transpose. So what I'm going to do here now is that I'm going to say A, B, A, and then I'll apply the transpose. So here I'm applying the transpose. So meaning I'm getting the commutative product. Okay, so meaning the transpose will go to this A. I'll write it as A transpose. The transpose will go to the B. I'll write it as B transpose. And then the transpose goes to that A. I write it as A transpose. Okay. Anyway, this one looks like it's just taking the transpose and putting it there and the like. Okay, because there are just three things here. Okay, so don't take it for granted because I might have different matrices. So let's say D, E, and then F. Okay, so you take the transpose of this. You first start with the last one. So it will be F transpose, E transpose, and then D transpose. If you write D transpose, E transpose, and then you put F transpose, this here will be a no. Okay, it will be wrong. Okay, so I hope you've gotten the concept there. So they like bringing this concept, make sure you understand it fully. Okay, the product of a transpose or the transpose of a product, whatever the English is there. Okay, so this is what I get when I distribute the transpose to this. So now here I was told A and B are symmetric matrices. So meaning A transpose is equals to A, B transpose is equals to A because they're symmetric. So I'll just replace where there's A transpose, I'll replace with A. Since A is symmetric, B transpose I'll replace with B. And then A transpose I'll replace with A as well. So we can see that A, B, A, and then transpose is simply giving me ABA. Okay, and this condition is satisfied. So meaning that this guy is indeed, it's indeed what? Symmetric. Okay, I'll go to the other part. So the other part says, is AB necessarily symmetric? Justify your answer. Okay, is AB necessarily symmetric? So if AB is symmetric, then AB transpose should give me AB. Okay, if this here is achieved, then I'm going to conclude that my AB is actually symmetric. If not, I'm going to say no. This can't be symmetric. Okay, so let's try. So AB transpose. Okay, let's apply the transpose to this product. So it will just be equals to B transpose and then A transpose. So the committed product like that. Okay, and then we were told A and B are symmetric there. So meaning I can replace the B transpose with the B, then the A transpose with the A. So what we see is that A B transpose is actually equals to BA. It's not equal to this. Okay, so is AB necessarily symmetric? We're going to say no. Okay, it's not necessarily symmetric. Okay, it's not necessarily symmetric. We are going to refuse that. Okay, and then they're saying justify your answer now. So we can easily justify there. We can see that AB transpose is not equal. Not equal to AB. Instead, it's equal to BA. So it's not necessarily symmetric. But this can be symmetric, okay? It can actually be symmetric under a certain condition. So I can say AB is symmetric, okay? If and only, okay? If and only if A commutes with B. Okay, if and only if A commutes with B, i.e., if AB is equals to BA, then we can say that AB is what? Symmetric. Okay, so in general, AB won't be symmetric because of what we've stated there. But if we are to come up with a condition that will make AB to be symmetric, then it has to be that A commutes with B, i.e., AB is equals to what? To BA. So that's how we can simply answer that question there. All right, so for those who would like to access more videos, okay, on different topics in linear algebra, okay, we have a website full of videos, okay, that can help you prepare for your tests, for your exams, for your quizzes, and simply how to solve these things. Okay, so on our website, we offer these courses that you can see here. There's linear algebra, um, there's financial mathematics, okay, there's introduction to linear analysis, there's probability and statistics, there's engineering mathematics, and analytical geometry and calculus. Okay, so in all these courses, our aim, okay, is to provide quiz paper solutions. So that is in video form. Okay, we're explaining clearly how to solve all the questions in the quizzes, all the questions in the tests, all the questions in the tutorial sheets, all the questions if you are given any assignments, okay? And also we provide full video solutions to final exam past papers so that you know how the exam what comes. So all these, you can actually find them at discretelearning.com. So if you want to contact us or get in touch with us, okay, you can use this number here or this number. So you can give us a call or you can WhatsApp us and we're going to help you. Okay, so let me show you the website. So just go to Chrome. Okay, so here on Chrome, just type in discretelearning.com. Okay, and then you go to the website. Okay, so you can see this is the website here. So if you don't have an account, you first need to create an account, right? So you put in your details, your name, your email, you set the password for your account, okay? And then you use it to log in. So once you log in, there are a lot of courses that we offer. So if you're interested in higher math courses, okay, you just skip this one. These are for first years. But if you have a friend who is in first year, you can refer them to us. We have physics, biology, chemistry, uh, and math. Okay, so for those who are in higher math courses, okay, you can see there's linear algebra here, introduction to real analysis, there's analytical geometry and calculus, statistics and probabilities there, financial mathematics, engineering mathematics. You can well ask refer someone you know who is doing medical courses. So like they are having anatomy, biochemistry, human physiology, statistics, economics. You can refer all those people, even those who are writing grade 12. So we have grade 12 mathematics there, grade 12 science, that's physics and chemistry, biology, civic education. Okay, we have English language and more courses that we are going to be adding to this platform. Okay, so in this video, I just want to show you the linear algebra folder, okay, or the linear algebra course. So you just come here on the website. So if you are not subscribed, then you won't be able to open this. So you need to subscribe, okay? So here you can see on the corner, there's enrolled, meaning you are subscribed. So if you're not yet subscribed, here there will be not enrolled and it will be in orange. And then once you subscribe, it has to turn green and then it has to write enrolled. So make sure that when you enroll, this thing changes there. So if I open this course here, you can see what I'm going to have. There are some topic lessons that we uploaded there, summarized notes on all the topics that you're going to cover in linear algebra. There are tutorial sheets and assignments here and past quiz tests and exam papers. So the arrangement is the same even with the other with the other courses, but I'm just using linear algebra. So if, for example, I go in this folder for the tutorial sheets, okay? So you're going to see that there are video solutions here and also written solutions to tutorial sheets. So you can open video solutions, okay? You're going to find all the tutorial sheets that you're going to have. Okay, so from tutorial sheet 1 all the way up to tutorial sheet 7, okay? So there are 7 topics. So there are basics of matrices like addition, multiplication of matrices, subtraction, transpose, how to find the inverse. You're going to find those questions in this folder, okay? And then you move to systems of equations. So you're solving simultaneous equations using matrices. Okay, so there are different methods that we can use. You can use Cramer's rule, you can use the Gauss-Jordan. You're going to find the videos here. And then talk about the determinant and its properties. You're going to find the full videos there. This is what now vector spaces. You're going to find the full videos there. linear transformations, you find the full videos there. Inner products, they are there. Engine values and eigenvectors, you're going to find them here. So for example, if I open tutorial sheet 1 here, where we have the basics of the matrices, you can see here we have the videos well arranged, okay, and well titled. So if, for example, you are looking for a concept that you want to learn, you can simply look for that title. So for example, I want to learn how to construct matrices, okay, using specific given information. You can go to find this video here. So you can just open it and then you watch and you learn at your own time, at your own pace, even in your what? In your blankets. So I think this tutorial sheet has about 19 questions, but we are still adding more videos. Okay, so we're still adding more videos on different concepts that are basics of what? Matrices. So it's the same with all the other folders that you saw there. Okay, so the questions that we're using are actually here. I can even show you the questions here. So I'll start from tutorial sheet 1 here. So you can see the kind of uh, questions that you are going to be asked in tutorial sheet 1. So you can see all these questions here. Okay, these are tutorial sheet 1 type questions. And then again, this is tutorial sheet type questions where I was saying construct matrices. So for example, find 5 by 5 matrix A whose entry says satisfy the stated condition. So these are the stated conditions. You can see all these things here. Okay, why is it not moving? Okay. Okay, I know why. I am on a pencil. So you can move down here. You see all these questions here were solved. The videos are there on the website. You can use them to learn at your own time, at your own pace. Tutorial sheet 2, systems of equations. We have this guy is here. So, what's happening now? Okay, so all these questions here, you can see them. They were solved and they are on the website waiting for you. Tutorial sheet 3, determinants. We start with the properties here. We explain uh, very well how to do or how to go about them. And then we evaluate the determinants for these matrices. We use the properties of the matrices. All these questions are there to help you understand the concept. We go vector spaces. So all these questions that you can see are also there to help you understand whatever you want to understand. This is what now, linear transformations as well. We have some questions here that can help you understand. We go to inner product spaces. So inner product spaces are also known, or this topic is also known as orthogonality. Okay, so you can see we have questions there that can help you, like applying the gram schemed orthogonalization procedure. You can see it there. We showed clearly in the video how to do that. I think the last tutorial sheet that we have now is on eigenvalues and vectors. In future, we'll apply. In future, we're going to upload also on quadratic forms, and all those tutorial sheets are going to be available on the website. So yeah, so all these questions here can help you actually to study effectively and know whatever you are doing. Okay, so we'll also be uploading full video solutions to past papers like quizzes, tests, final exam papers, so that you guys can be learning at your own time, at your own pace, even in your what? Even in your what? Even in your blankets. Okay, so if you like to register, okay, just follow the link in the description below of this video, okay, that you are watching. It's going to show you, okay, the process on how you can actually register yourself. So check the link in the description below here. So it has a link to our website, which is discretelearning.com, and a video, okay, a video registration guide, which you can watch to know how to register, as well as it has the link to our mobile app, okay? So the good thing about our mobile app, so just go on Play Store, you search Discrete Learning Institute. So the app is going to come, you use the details that you created on the website to log in. Then once you log in on that app, okay, you can actually download the files, especially the videos. You can download the videos on the app, and then you can even watch them what? Offline. Okay, you can even watch them offline. That's the good part about the app. So make sure you download the app, Discrete Learning Institute, so that you can be downloading all these videos for the tour sheets, so that you don't always have to use what? Internet when you are wanting to study or watching a video. So contact me on this number if you need more information, okay? but you can actually self-register. Just follow the link in the description of this video. So thank you so much for watching this video. Until next time, this has been Tutor Solutions, always there for you.